Hi everyone, welcome to my talk. My name is Dr. Swami Haladi. I work as Global Program Manager for Trout Nutrition, managing the mycotoxin area. So today I will be speaking on the interactions of mycotoxins, the reasons for these interactions, and also touch upon the integrated approach to manage mycotoxins, which has been challenging to us all around the world. So I'm sure all of you know that the mycotoxins are secondary metabolites of various molds, and more than 80% of agricultural commodities are contaminated. This means there is a presence of mycotoxins. May not be a significant effect to the animals, but they are present. And as you all aware, FAO back in 1985 it was only 25%, but today 80% of the agricultural commodities are contaminated with one or the other mycotoxins. And all these mycotoxins, some of them are produced in the field and some of them in the storage. The biggest challenge for animal industry is they're highly heat stable. That means even the pelleting extrusion will not kill these mycotoxins. So that is why it is a big concern to us. They can be produced in grains, which are commonly used in poultry, like wheat, barley, and maize, but also various protein sources to a lesser extent. And also the byproducts are a major source because generally a rule of thumb is the mycotoxins in byproducts are increased by 3 times as compared to those present in the grains. So there are more than 600 mycotoxins that are known today, but for the purpose of rapid testing and for easier understanding, there are 6 mycotoxins which we need to be aware of at this stage, which is nothing but 4 of them comes out of the Fusarium mycotoxin group, like T2 toxin, deoxynivalenol, zearalenone, and fumonisin, and 1 each coming from the Aspergillus and the Penicillium toxins, which is aflatoxins and ochratoxins. An interesting point to note here is the Aspergillus fungus produces both aflatoxins and ochratoxins depending on the environmental conditions the crops are being grown. So ergot toxins are obviously important in the ruminant animals, and it is important to a lesser significant in case of poultry. And the major point actually I wanted to focus on this is, in reality today, there are many mycotoxins, what we call them as emerging mycotoxins. These emerging mycotoxins are those mycotoxins that are not routinely analyzed, that are not regulated by any legislative group. However, the presence of these mycotoxins is significantly increasing, and there is a big list of that, as I mentioned here. But I think the one significance are fusaric acid, moniliformin, bevoracin, and enantins are becoming a major challenge. Particularly in Europe, there is a lot of research going on in this particular area. Another aspect of why the interactions happens is because of the presence of masked mycotoxins, and both in US and Europe there is a lot of research is going on at the moment to understand the impact of these masked mycotoxins. These masked mycotoxins are nothing but the toxins that are present in the feed. They cannot be analyzed due to the different molecular weight, but once these mycotoxins get into the gastrointestinal tract of the animal, the toxins get released. For example, deoxynivalenol is a big problem in US and many other countries, and DON3 glucose is the masked mycotoxins. So DON3 glucose, when it goes inside the chicken, becomes DON, which is again cause a problem in a poultry and also other animals. Just to give an example of various masked mycotoxins, there is DON3 glucoside. There is also nivalenol, which is again a Fusarium toxin. T2 toxin is a masked form. HT2, zearalenone, And in fact, now more research is going on aflatoxins and as well as fumonisin. So that is how the interaction is happening. Why we are talking about interaction, mycotoxin interactions, is because one mold can produce many mycotoxins. For example, one Fusarium fungus can produce 15-20 different types of toxins. And we also know that many molds can be present in one raw material. So obviously, more molds are contaminated, you have more mycotoxins adding up. And in poultry industry, we all know that the poultry feed contains 4 to 5 different ingredients. For example, maize, wheat, or soybean meal, and some countries they use rice bran and wheat bran. So again, DDGS is significantly used. So more addition of raw materials is increasing the number of mycotoxins. So this all leads to the multiple mycotoxins in one feed, obviously, and which causes mycotoxin interactions, leading to higher risk for adverse effects, which is more than what you can expect from a single mycotoxin. So that's why we call today mycotoxin co-occurrence is a rule and it is not an exception. So there are 2 different types of interactions that are mainly studied in poultry. One is called as the additive mycotoxin interactions. A lot of research has been done. Additive interaction means 1 + 1 is equal to 2. That means if you have a combination of aflatoxin and DON, for example, you see an additive interaction. If the birds are losing 100 grams of body weight for aflatoxins, if the birds are losing 100 grams of body weight due to DON, when they are together, they lose 200 grams of body weight. In case of synergistic mycotoxin interaction, which is a challenge to our industry, is there the impact is, if you add 1 + 1, it is more than 2. If you take the same example for these, for example, aflatoxin and T2 toxin have got a synergistic interaction in poultry. There you will, if the impact of aflatoxin is 100 grams, if the impact of T2 toxin is another 100 grams in a separate studies, when they're together, you will see a loss of more than 200 grams of body weight. So this is just an example of 2 mycotoxins. You can just imagine what happens if there are 3, 4, 5 mycotoxins in the same feed. So ultimately, these mycotoxin interactions, are posing a challenge to the diagnosis. Because of the interactions, you cannot diagnose the problem properly that is present in the feed, the challenge present in the feed. So obviously, you will not take an action because you think that the level of individual toxin is below the action limit. So ultimately leading to a dangerous situation for our industry, maybe in terms of rejection of raw materials at the port, maybe at the feed mill as well, or losing money because of the loss of body weight, egg production, and also in many countries, the regulatory compliance, because some of these mycotoxins can get into milk, in case of cows, obviously in poultry, meat and eggs, leading to a challenge at the regulatory level. So some of these adverse effects of mycotoxins in poultry, I'm sure we all are aware of that. Depending on the type of toxin, the liver system is affected, the kidneys, the gastrointestinal tract, the digestive tract is impacted significantly, leading to a wet litter. Malabsorption syndrome is also detected in case of poultry. And we have seen the cases of leg weakness, both in layers and broilers, attributed to a Fusarium mycotoxin called Fusarochromonone. So DON and T2 are shown to cause intestinal lesions, and many of the mycotoxins, particularly the Fusarium toxins, are increasing the translocation of bacteria into the lumen of the intestine, leading to a poor gut health. Also, the presence of toxins like aflatoxins can reduce the pigmentation and also can reduce, decrease the production of feather, a protein responsible for feather production. So just to give an example, I would not spend more time here due to the lack of time. There is a clear example of mycotoxin interactions happening. in causing embryonic mortality in case of breeders, affecting the calcium, vitamin D3 and phosphorus, utilization in the animals, leading to the thin eggshells. Ultimately, thin eggshells will lead to the increased embryonic mortality. The aflatoxins, ochra, T2, and DON are actually interacting in this regard. And on the right-hand side, you see the immune system. The immune system comprises of both the B cells and the T cells, and also many of the natural killer cells. All are getting impacted, leading to the poor immune system and increased mortality and morbidity. So ultimately causing losses to the in the poultry producers. So there are many different steps we need to take in order to control these mycotoxin interactions, because as I said, different mycotoxins are produced during the different stages of the plant growth. Some are produced more in the field, some are produced more in the storage. So I have come up with a 10-point system, starting from the soil management in terms of flowing, which is not done in many countries today. The second point you can see is the crop rotation, that not using the maize after maize growing is not recommended. You rotate the crops, also reduces the fungal growth. We have seen that in many situations. And then obviously during the harvesting, unseasonal rains are causing a lot of challenges. So how best we can harvest the grains at the right maturity and store them is also very important, not being exposed to the rain. So during the storage in many countries, obviously the grains are held at the warehouses for a period of time. It can be from 6 months to 1 year, depending on the usage of the raw materials. So during those, it is highly recommended to use an effective mold inhibitor to reduce the growth of the fungus inside these silos. Obviously, you need to manage the silage temperature, humidity, and those areas. And the next one is transportation. In some countries, the grains are transported from a long distance. So during those conditions, we need to make sure that the grains are not exposed to the rain and other unfavorable weather conditions. So from the feed mill, obviously, the grains goes to the feed mill, and feed mill is a place where we have seen a significant increase in the mold growth and mycotoxin formation, because the grains are kept for a long period of time. And even during the processing, the various parts of the feed mill has to be cleaned. We should avoid the formation of dust and the crusts within the mills, and obviously very sound HACCP program has to be in place. So for that, it is essential that we use a very rapid analysis of mycotoxins using ELISA-based methods, particularly lateral flow technology has been used significantly. Like MycoMaster have been very successful in helping the customers around the world, and it analyzes 6 different mycotoxins in a short period of time and provides a quantitative analysis, and this can be used for both feed as well as raw materials. That is the big differentiation, is the MycoMaster can be used to treat the analyze the feed in addition to the raw materials. And obviously what we do with this information, we collect the information from different MycoMasters coming around the world, and we develop a database and provide some early warning to our customers about the potential threat of these mycotoxins, to project how to minimize the challenges. We go one step forward and also develop the tools where, depending on the species, it will show the risk analysis of various mycotoxins. In fact, within poultry, we have divided broilers and breeders and layers. So again, at the bottom of this, you can see there is a risk analysis for various species of animals. It can be done for pigs and ruminants also, that will indicate high risk or low risk or medium risk. Based on that, a preventive approach can be applied. And the last point in this is a couple of points, is also use of some kind of mycotoxin binders are recommended in some parts of the world, that they can certainly help. And obviously the feed has to be transported to the farms. During those also we need to manage right conditions of the transportation. And once it reaches the feed mill, storing the feed is very critical, because if you provide a very good quality feed reaching the feed mill, and if you don't store them properly well, all the efforts you put in the previous 9 steps will be compromised. So store the in a dry conditions, and also provide some supportive treatments with good management practices for to take care of the health of the animals. So the management also plays a very important point. So with this, I would like to conclude that mycotoxin management has to be an integrated approach, and this is more important given the fact of mycotoxin interactions among various mycotoxins we know today. Thank you so much for your patient hearing.